All right, so let's go ahead and take a look at the second example. So it says you're planning to buy a new car and have limited your choices to two cars, the Chevy Volt, which is a hybrid electric car, and a Dodge Dart, which just is a pure gasoline car. Study the information below and make a spreadsheet to compare total monthly costs of the car up to a point that the numbers are equal. Okay, so I'm going to go ahead and I'm going to start building myself a little table here for my two different cars. So I'm going to do my gather information step. Okay, and I'm just going to sort of fill this out as I go. So we have two cars. We have the Chevy Volt and we have the Dodge Dart. So it tells us that the cost of the Chevy Volt is between $26,670 and $34,345. So I'm going to assume I want the nicer trim level. I'm going with the $34,345. Okay. All right. It gets 38 miles on a full charge. So miles per charge, 38 miles, which costs $1.70. So cost per charge is $1.70. And then it takes 10 to 16 hours to charge. So time per charge. Let's just go with 16 hours. Okay. All right. And then gas mileage. So the average is 37 mpg city and 40 mpg highway. All right. So that is our Chevy Volt. Right, now let's go ahead and take a look at what it tells us about the Dodge Dart. So it costs $16,495, so significantly less. It's not an electric car, so none of these fields right here apply. I'm just going to gray those out. And the gas mileage is 22 mpg city and 35 mpg highway. Okay. The other thing I'm going to add to this, because we're talking about prices, we're talking about gas mileage, I'm going to add in here the price of gas. So on my way into work this morning, I passed the Shell station, and the current price of gas that I saw was $3.19 per gallon. Let's just go with that assumption for what we're looking at here. Okay. All right, so I think that is all the information that we're given. So then we want to come up with a reasonable answer. All right. So just looking at the cost of these cars, obviously the Chevy Volt costs a heck of a lot more than the Dodge Dart does. So it's going to take a pretty significant amount of time in order for the Chevy Volt to be worth the cost to make up for what it's gaining in gas mileage to account for that extra price at the beginning. So I would say it's probably going to take a lot of years in order to make this Chevy Volt worth it. But let's just say I'm going to assume that it costs maybe about $40 a week to fill up the Dodge Dart. Okay, that's kind of just looking at the gas mileage there of 22 to 35 mpg. I think my husband's truck gets like 20 think is about $40 a week. So let's assume it costs about $40 per week to fill up the DART. Okay, and let's just say this is about the amount of money that you're saving. Because on a typical week, probably the Volt, you can go off with the electricity and not have to fill up the gas very often. So that $40 per week would be something you're spending on the DART, but you're not spending on the Volt generally. So $40 per week, if there's 52 weeks in a year, this is about $2,000 per year. Okay, so that's about $2,000 per year that you're spending in gas on the DART that you're not spending in gas on the Volt. So if we look at just the price difference between these two cars, so $34,345 minus $16,495, there's a roughly $18,000 price difference between the cars. So with about an $18,000 price difference between the cars. So if we're saving about $2,000 of gas per year on the Volt, and we have to make up an $18,000 price difference, it would take about 9 years to make the Chevy Volt worth it financially. Okay, so a reasonable answer, let's assume that gas costs about $40 per week to fill up the DART, which is about $2,000 per year. With an $18,000 price difference between the two cars, it would take about 9 years to make the Chevy Volt worth it financially. Okay, so I made a lot of assumptions there, but I'm just trying to get kind of a ballpark answer. So it's safe to say then probably if you're only planning on having this car for 5 years or so, which a lot of people, they buy a car 5 years, 7 years down the line, they trade it in. If you're only planning on having this car for that time period, then financially it's probably not going to make any sense for you to buy the Volt. Now, of course, you could argue that environmentally there's lots of reasons that you might want to buy the Volt, but if we're talking sheer numbers, then probably if you're going to own this thing for under 10 years then it's probably a better idea just to go with the DART. Okay, so now let's actually go ahead and solve this thing. Okay. All right. So we need to go through and think about the different fuel costs for the Volt and for the DART. Okay. So I'm just going to assume, I would say probably the average person drives about 12,000 miles a year. And let's just assume about 10,000 of those are city and 2,000 are highway. Okay, let's assume you drive 10,000 city miles and 2,000 highway miles each year. Okay. Obviously, this is going to vary from person to person, but we're just kind of coming up with a generic situation here. Okay. All right, so if we're looking at the DART, okay, let's look at the cost for the city miles to start with. Okay. All right, so if we're assuming that you drive $10,000, or $10,000, you drive 10,000 miles per year. All right. And the DART in the city got 22 miles per gallon. So for 1 gallon, you can go 22 miles. and we're assuming that gas costs $3.19 per gallon. And then if we multiply this out, so 10,000 divided by 22 times 3.19, it's going to cost about $1,450 per year to drive the car in the city. So, let me say here, cost of gas in the city. Okay. All right, so then we also want to find the cost of gas on the highway. So for this, we said we're assuming 2,000 miles in 1 year. And on the highway, it said the DART gets 35 mpg. So 1 gallon is going to get you 35 miles. And then again, assuming gas costs $3.19 for 1 gallon. So I have too many zeros over here. So 2,000 miles divided by 35 times $3.19 would be about $182 per year. Okay, so the total cost then, if we just add up the $1,450 plus 182, it's going to cost about $1,632 per year in gas on the DART. All right, now let's go ahead and let's take a look at the volt. Okay, so if we look back up at our information here, we were told that the volt can travel 38 miles on a single charge, and it costs $1.70 per charge. So if I think about my typical daily commute, I would say I drive less than 20 miles a day. So if at the end of every day I went home, I plugged in my car, left it overnight, then by the morning I should have enough of a charge, because if it's 16 hours for a full charge, then I might not get a full charge in that amount of time, but I'm going to get pretty close. I'm going to get close enough to at least get me to work and back on that charge. Then I could probably go most days without even using any gas. So I'm going to say, let's look at the cost of electricity for the volt, because I think that most of the time I'm going to be using electricity when I'm driving around town. So it costs us $1.70 per charge. And I'm assuming I'm going to charge it once every day. Okay. And, you know, I might not drive my car every single day. You know, weekends, maybe my husband will drive, or I might have a day off here or there. So I'm going to assume maybe I'm driving my car, or I'm charging my car 250 days out of the year. Okay. All right. You could up that a little bit if you drive more frequently, if you're driving every single day of the week, but typically for me, I'm not driving on weekends. I'm only driving Monday through Friday when I'm going to work. Okay. All right. So 1.7 times 250 would cost us about $425 per year in electricity. Okay. All right, so then we could also find then, so then if we're going to go on the highway, which we're still assuming about 2,000 highway miles per year, once you get on the highway, you're going to be going typically more than 38 miles, and you're going to have to start using the gas instead of the electricity. So I'm just going to assume that all of my highway miles are using gas. Let's say cost of gas on highway. So 2,000 miles in 1 year. And let's see, what did it tell us? The volt was 40 mpg highway. 40 mpg highway, yeah. So 1 gallon per 40 miles. And then we're still assuming that gas costs $3.19 for 1 gallon. So 2,000 divided by 40 times 3.19, it's going to cost about $160 per year for gas on the highway. Okay, so then my total cost here, $425 plus $160 is about $585 for the electricity and the gas on this car. Okay, so now remember what this was asking us to do was to make a spreadsheet to compare the total monthly cost of the car up to the point that the numbers are equal. Okay, so I'm going to go ahead and pull out Excel. I'm going to create a new spreadsheet. So I didn't quite follow the instructions. I just realized because it asked us to find monthly costs, not yearly costs, but that's okay. We'll still get a good idea. Okay, so if I want to make a spreadsheet over here, I need the years, I'm going to need the cost of the volt, and I'm going to need the cost of the dart. So one easy way if you're in Excel to get it to count for you, like if you're doing years, just enter a 1 for our first year. And then if you click on that cell, take the little corner and you can drag it down. So drag it as far as you think you might want to. And you'll notice that all of these say 1, which is obviously not what we want. But then if you click on this little guy right here, you can say fill series. And then it actually counts for you by years. So that's an easy way to get it to do the work for you. Okay, so now I need an equation to come up with the cost of the volt by year. So anytime you want to do an equation, you enter in an equal sign. That's going to tell Excel that it's doing some kind of calculation for you. So the cost of the volt was the initial cost, which we were assuming the high end of $34,345. Then in addition to that, it's going to cost us $585 in gas per year. So $585 in gas per year. So we'll multiply that by the year. So I'm going to hit times, which is actually the little asterisk, so let's shift 8 when you're in Excel, and then I'm going to click on the year 1. Okay, what that does is for every single one of these, it's going to take the year that's next to it and do its calculation for that. Okay, so I'm going to hit enter right there, and then just like I did before, I'm going to click on this top cell, and then I'm just going to drag it down. And then that's giving us the different total costs of our car for all these years 1 through 39. Okay. All right, so then I'm going to do the same thing for my Dart. So equals the initial cost of the Dart, which was $16,495, and then plus the gas, which was $1,632, times, and I'm going to click on that year one again and hit enter. And I'm going to take the corner of this and again drag it down so Excel will keep doing those calculations for me. Okay, so now let's look at these numbers. Let me make this a little bigger. Okay, so if we look at this, we're basically looking for when does the cost of the Dart become greater than the cost of the Volt. So if we're looking at this, just kind of looking at these numbers, pretty close right here on year 17, right? They're almost exactly the same on year 17, but by the time we get to year 18, the Dart officially costs more than the Volt. Okay, so year 18, the Dart will cost more than the Volt. Okay. All right, now if we look back up at our original guess or our reasonable answer that we came up with, my thought was that it would take about 9 years for the Chevy Volt to be financially feasible or to be financially worth it, okay? Looking at our calculations, looking at our spreadsheet, we came up with a significantly higher number than that. We were looking at more like 18 years instead of 9. So I can't really say that these numbers are very close to one another, but we did make lots of assumptions along the way in both cases. You know, we assumed a certain amount of miles that we were driving. We assumed a certain gas price. We assumed a certain number of times that we were charging the car per year. So possibly, depending on how much you drove, how much gas prices cost, we could maybe get closer to that 9-year mark than the 18-year mark. So I would say it's not unreasonable. It's just a little bit different than what we came up with originally. So if we're to judge the soundness, I would say, although I can spell, our calculated answer is quite a bit higher than our reasonable answer, it still seems sound because depending on your driving habits, the number of years could increase or decrease quite a bit. Okay. All right, so in conclusion, according to our calculations, it will take about 18 years for the Chevy Volt to be financially worth it. All right, and we are done.